going to do something kind of fun today. So I'll tell you a little bit about the Glowforge. We'll talk about how it works. We can talk a little bit about some of the science and the art. We can talk about how you can create something in your local makerspace with a laser that's there, or how you could do this with a Glowforge. And the whole time, we're actually going to design and print something from scratch, from a blank screen, which you've seen a few times because we've been playing around with a blank screen. And in order to do that, it's going to take 3 collaborators. It's going to take 1 designer, it's going to take 1 narrator, and it's going to take 1 art director. And so I'm wondering if there's anybody who would like to tell Shell about a bracelet that they would like, and describe a bracelet. Maybe share an animal with her that she could draw for a bracelet.
No
Is there?
Not a horse.
And no horses. We have a strict no horse rule. Is there anybody? Oh, did I see a hand? Yes? Come on over. What's your name? Jenica? Did I get that right? Jenica, come on over here. I'm going to introduce you to Shell. We're just going to kind of thread the winding cables and come over this way. Shell would love to draw something for you. So why don't you whisper in her ear an animal. Don't let anybody hear. Okay, now shout it to everybody.
Puppy.
Puppy! Excellent choice. Okay, Jenica, would you like to hang out here and sit and watch Shell, or would you like to wait in your seat while we work on this? Your choice. We can grab you a chair. You'll sit here? Awesome. Okay, so Lyndon will bring you over a chair. Lyndon is one of our software designers. She's the one who made the software you're going to see later, which makes the whole thing work. So Shell right now is using a software package called Adobe Illustrator. Lots of you may have run across this. It's a sibling to Adobe Photoshop. It's a vector design software package, which means it works in lines and drawings and fills, as opposed to something like Photoshop, which works with bitmaps and photographs. By the way, everybody should feel free to totally ignore me and watch Shell draw, because it is utterly hypnotic and I'm going to have a hard time not staring myself. So you have a host of different ways to design. Adobe Illustrator or Inkscape, which is a free software alternative, are things that we use often in the office. Anything that can output a PDF or can output an SVG is likely to be a vector package. There's also a lot of really cool new software packages that can do that. And those are the languages that the Glowforge speaks natively. It also can take bitmaps. So you can take a JPEG, like a photo, and upload that. And so you can take pictures, you can take digital artwork that you find, and you can combine those with your vectors. You can use those by themselves to create your artwork. You can use CAD software, which will let you create really complex 3-dimensional products. Like if you go by our booth, you'll see an enormous dollhouse, which you can make on a Glowforge Basic just like this. This enormous dollhouse was done in CAD software. The CAD software will create the 3D model, which you then slice up into pieces and use with a format, typically DXF or one of the similar formats, to go print on the Glowforge. Or, my personal favorite, if you come by our booth, you can see people actually designing products from scratch with just a pen. So you'll see there's a Settlers of Catan set. Settlers of Catan? Yeah, I see a bunch of nodding heads. Settlers of Catan set, where the designer, despite being a program manager at Microsoft, didn't use Photoshop or Adobe Illustrator at all. She did the whole thing with pen and ink. And she drew the entire Catan set triple size, and then put the paper in the Glowforge, which scanned it, shrunk it down, and then engraved and cut it onto materials. So you can choose any of those. Now, I just mentioned engraving and cutting. There are a few basic things that a Glowforge can do. Now, I should mention the Glowforge falls into the category of CNC laser cutter engravers. That's the technical term for the category that includes Glowforges. Your local makerspace may have a CNC laser cutter engraver. Schools sometimes have them. They're normally quite big, they're quite bulky, and the software can be really challenging to use, which is why we created Glowforge. We refer to it as a 3D laser printer, because like a laser printer, it can print at over 1,000 DPI, grayscale, black and white. Unlike a laser printer, it can actually cut and process and create 3-dimensional products. So you've got a few choices for how to do that. You can cut. When you cut, the laser moves slowly at high power and actually vaporizes the material underneath. And the amount it removes is about 6 1,000ths of an inch to 10 1,000ths of an inch, about the width of a human hair, on the thick side of human hair, but about the width of a human hair. And so it lets you cut out materials. It can also engrave. When it engraves, it moves back and forth, which is called rastering. And the laser fires with a precision of less than 1,000th of a second to vaporize the surface layer of the material. And again, you can move it faster or slower at higher or lower power. You can also adjust the focus, so you can have a really tight, precise spot or a broader spot more spread out. Now, with Glowforge, it mostly takes care of that for you. You can bring your own materials, and then it takes a little experimentation, or you can use our materials, which are called proof-grade materials. They actually come with a paper on top, which has a UV barcode. And embedded in that barcode is all the information the Glowforge needs to tell you how you'd like to do it. So you can decide if you want it engraved light, engraved dark, engraved 1 millimeter deep, 3 millimeters deep, how far you'd like it to go. So you'll see the interface for doing that in just a little bit. Are we happy with that, puppy, or are we gonna? We have approval. We have design approval?
We have design approval.
Excellent. So you'll see there's a little icon. Do we have the icon, or are we just exporting?
We can bring up the icon.
Okay, we'll bring up the icon. So there's an Illustrator plugin, which just gives you a button to push. And that button takes this design, turns it into an SVG, and then sends it to our cloud service for printing. Now, if you don't have the extension installed or you're using software we don't have a plugin, you just save it as an SVG and then drop the file onto the web service. So in a minute, you're going to see Shell's going to open up a web page that's going to have the, oh, that's right, we're going to design the rest of the bracelet. Okay, I forgot. We have the artwork, but the artwork isn't enough because we're building the whole product from scratch. So Shell is using these lines to represent the cuts and scores that are going to create this bracelet from the materials that you chose. Looking good so far? Looking good so far? Excellent. So when she hits print, it goes from the computer to our cloud service, via Wi-Fi in this case, but however your computer's connected. The cloud service brings up a web page so you can see what it's going to look like, and actually superimposes the design on the material in the bed of the machine. So as those of you who were here before probably saw, there's a camera right here in the lid, and anything that is in the bed will be shown in the browser, and you can just position everything on top of it. Now, what's cool is because this is in the browser, this works on a PC, this works on Mac, but you can also use it on tablet, you can use it on iOS, you can use it on Android, you can use it on Linux. You have your choice of different interfaces to use it. And then when you're ready and you decide to print, it actually sends the print file to the Glowforge via Wi-Fi so that it's ready to go. That actually helps us bring the cost of the machine down. Typical laser cutter engravers are $10,000 and up, and we wanted to get out to a really affordable price point. So for the rest of the month, you can pre-order it for $23.95 for delivery in March of next year. At the end of the month, the price it will be going up somewhat. So if you are interested in doing this sort of thing, and you don't have a Glowforge yet, or you're not thinking about getting one, this is something you can do at your local makerspace as well. You create these designs and bring them in. And the way that it typically works is that the color represents doing an action. So a color might represent a cutout, or it might represent one level of engrave. And you will be manually assigning what they call feeds and speeds. So the power and the speed of the head and focusing and so on to create this. So Sodo Makerspace, Metrics CreateSpace are both great local resources that have lasers available for public use. We happen to think this is a little easier way to do it, but want to be sure that everybody does. Okay, are you ready to put the material in? Is she ready to put it in?
She's ready.
Okay, so I'm going to open this up. Do you want to switch over to the, come on over. Put it right there. And turn it over, because that's the sticker side. There we go. Is that good? Yeah. Okay. So, we've got the material in place. This little camera right here can actually view the entire 18 by 12 inch bed of the machine. So you can put a whole sheet of plywood in there and see the whole thing. Shell's still an illustrator. In just a minute, she'll move over to the software where you can see that bed image that we're talking about.
We actually just lost internet.
Oh, we just lost internet. So we'll be a minute while we get the internet straightened out and then show that. That's okay. Let's see. what you can see right here is actually the design library of all the things Shell's drawn recently. You can see she was practicing with some assortment of animals. I think we lucked out because Shell had just polished her puppy skills by the appearance of this.
It's a hard job.
Yes. So normally the design process you do, several times. You're going to print each one to see. Shell's been practicing so she could draw this from scratch from the very get-go. So when we get that back, you'll see it pop up in the Internet UI where you can demonstrate it. But let's talk a little bit about the actual laser that's doing all the work, because lasers are pretty cool. Now, the Glowforge has a 40-watt carbon dioxide laser. What that means is there's a glass tube inside the Glowforge. It's this big. It's liquid cooled, and it's full of a mix of gases, the most important one of which is carbon dioxide. Now, when it's time for the Glowforge to turn on, it puts a high voltage signal across the tube, and it lights up almost exactly like a neon sign. So when it's running, you'll see that the tube itself will glow pink. What's interesting, though, is because it's a laser, we're not interested in the pink light. The pink light is going out in all directions. It's called incoherent, which means two things. It means I have no idea what you're talking about, and it means not coherent. Coherent has a very special meaning when it comes to light. It means that every little bit of light, called a photon, is marching in lockstep. And when you have coherent light from a laser, when all the photons are marching in lockstep, you can get a beam that's very tight and that goes a long way without spreading out. Hooray, Internet! and that's what we use to make this work. So we've got, let's see. Oh, are you zoomed way in, Shell?
I'm also on the wrong forge.
Oh, okay. So you can actually connect to multiple different Glowforges from one interface. So if you're a school and you have 5 or 6 of them, we'll get back to the coherent light in a minute. If you've got 5 or 6 of them, you can choose. You can see this one has been affectionately named Fingerforge. And you can see there is the picture we were talking about from the head. So that's the material. Is that what you put in there? Can you tell? They didn't see. Can you tell everybody, is that what you put in? Thumbs up or thumbs down? Yes. All right. So Shell's now putting it into place. You could see she could resize it. She could drag it around. She could also add other things to it. So if you wanted to customize it with a drawing, we could put the drawing in there and have the Glowforge scan the drawing and put it on top of your bracelet. But right now, we're just going to go with this amazing little puppy that we did. So it's right now sending the design to the Glowforge via Wi-Fi. And as soon as it arrives, we'll know because this lights up. I won't notice it because I'm not staring at it, so wave and tell me when that thing lights up. That's an important part of the demonstration or we'll be here a long time. So back to the tube. Once this tube of gas is glowing, what's happening is incoherent light is going off in all directions. The gas is really excited, it's full of electricity, and it's spraying photons every which way. But there's something very special about this tube. The gas sends off a certain number of different kinds of light. And on either end, there are mirrors, which reflect some, but not all of the light. So when this starts glowing, you've got photons ricocheting back and forth, off into the wild blue yonder, everything else. Wi-Fi fun. Oh! Do you want to do it?
I'll go push the button. It's the best part.
Yeah, totally. See that? Just go boom! Yes! All right, and we'll switch over so everybody can see it. It's going to go really fast. Ooh. There we go. It's a little funny color, but that right there is the laser. And if you look really carefully, you can see it's turning on and off. So here's what I want you to imagine. Imagine you're in a tight hallway, packed with people. And everybody's close to everybody else. And everybody gets really wired on sugar. That's the electricity that goes into the tube. And people start bouncing around. And they're kind of bouncing around randomly, but somebody bounces into the person next to them, and what happens? It's like dominoes. It's like a chain reaction as it goes down one end, until they get to the end of the hallway, and then it stops, unless there's a mirror. So now imagine the end of the hallway is rubber, and so instead of bouncing into the wall, you bounce off the wall, and you go back, and the wave goes backwards. And the wave of people keeps going backwards and forwards, bouncing off of each other. And now, we make a little door, so some of the people get out. Well, all those people are going in the same direction at the same time. And that's what coherent means. It means every photon coming off the laser is moving in the same direction at the same time in lockstep, the same color. Now, I have a trick question for you. Does anybody know what color the light is? Anybody, let's say under the age of 15, know what color the light is? Comes out of a laser. Yes, person who I've never met before in my life, who looks a lot like me. Red. That's a reasonable guess. I mean, what are the colors of the rainbow? Red, orange, yellow, green, blue, indigo, violet, right? So you figure it's got to be one of those. It's actually not. My audience plant set me up perfectly. It's actually not red. It's infrared. The light coming out of the laser is completely invisible. We ready for another go? All right, button number 2. So the first time we cut a little bit of veneer, that is a thin slice of wood, which is going on top. And now we're going to cut a piece of acrylic, which is going to go underneath it so we get some color in here. So you can see the laser sliding up and down. I'm going to try and see if we can get the color by pulling this and plugging it back in again, because that worked before. And you can see, there we go. So you can almost see it's pink, because all the light that comes out, that's the incoherent light. That's pink and purple and blue. All the coherent light is infrared. And it goes down this tube in a straight line, and it bounces off of a pair of mirrors that are over here and comes back into this black box. You can't see it, but there's a beam of laser light right here where my finger is, going through the air into that black box. And in the black box is a lot of magic. There's a macro camera, so you can see really close up. There's an ultraviolet LED, so that it can see the UV barcodes on the material. There's a motor and a lens so that it can focus on the surface of the material. There's another laser, a little tiny one like you'd find in a CD player, that scans the surface of the material to figure out how thick it is, which lets us focus and even lets us adjust the design so that if you want one part to fit inside of another part, we can measure how thick it is and resize the design so your pieces fit together. All right, shall I pull this out? So we've got this. As I mentioned, the material is coated with this white paper, which does a couple things. It lets us print the barcodes on it. It lets us, it protects the material while it's being printed, because you can see there's some sort of like black discolorations here. I'll put it right here. There's some sort of, there we go, some kind of black discolorations. Those are going to go away as soon as we peel it off. And also what's really cool is you can draw on it. So if you want to cut a piece of material in half, you just draw a line on it. And then you open it up in the software and you click on it and it will cut right over the top of your line. In fact, you can even design the entire product from scratch just by drawing it and having it engrave and cut your coaster from your pen drawing without anything else. So, one other really special thing about coherent light is that you can focus it to a much tighter spot than incoherent light. So, has anybody ever used a magnifying glass to burn a leaf, to make a really hot spot? Or a solar oven, which is like a huge magnifying glass and gets food really hot in a small area? That's all about taking a whole bunch of photons and putting them all in a really small space. It's called power density. Power density can do amazing stuff. Now, the laser only puts out 40 watts of energy. That's the same as a 40-watt light bulb. If you think about a 40-watt light bulb, that's kind of a small one. It's going to get hot, but it's not like, you know, amazing vaporize acrylic hot. But when you take all that energy and put it into a coherent light beam, and then you use a lens to focus that energy down into a spot that's just a few thousandths of an inch thick, that's when really amazing stuff happens. That's when you can cut and engrave straight through the material and make these incredible kinds of designs. Related, using infrared light is important because different kinds of light are absorbed or reflected by different colors. You probably know on a hot day, white things stay cooler and black things get warmer. Now, what's interesting is, if you shine a red light on something that's red, it's not going to get very hot because it's reflecting all the red light back at you. But if you shine blue light at something that's red, it's going to warm up. So different materials absorb and reflect different colors of light. Well, here's what's cool. Acrylic, leather, fabric, paper, wood, all the things that we love to make things with absorb infrared light really, really well. So they're very efficient at turning the beam from the laser into patterns that you can, or into projects that you can work with. So you can see I'm going to put a piece of, this is leather here. Put a piece of leather down, I'm going to close the lid, and as soon as I close the lid, did you see it said your picture will be done before you know it? Again, this is actually a web browser that's running in Google's cloud that's talking to the Glowforge via Wi-Fi, and they're tightly linked. So as soon as that lid closes, it starts pulling up the image. So now it's taking the picture, and it does take a while to move the whole image across conference Wi-Fi. They've been very good, but the Wi-Fi is a little busy. But in just a minute, you'll see it pop up here, ready to go. And then, again, you can drag this around. If you're on a tablet, you can drag it around with your finger, and you can figure out exactly where the design is going to go on the material and make the most use of your material. So this will be the last piece that we print, and then we'll be able to go assemble this and put it together. And so at this point, I'm going to take a question or two, because while we're doing this, I can take a couple questions, and then we'll have final assembly. So if there's anybody who'd like to ask questions, put up a hand. Yes, my other not audience plant who mysteriously looks like me. What's that? Don't have a question. Hi. Yes.
I'm a teacher and I'm interested in something like this at my school, and I was wondering how, well, obviously it must be user-friendly, so somebody needs to be trained in how to run this and be the expert in it, so is it pretty easy to...
So the question was, for a school, is this something that's easy to learn, and is it something that needs special training? One of the things we really work to do with the Glowforge system is try to take out a lot of the specialized skill. So if you come by the booth, you'll see people, young kids, using a pen to go design a product from scratch. We also have a catalog where you can purchase patterns that are ready to go. Just click, and it is guaranteed to print every time. But to do really amazing creative stuff, it's going to be proportional to the skill you have with your design tool. So if, like Shell, you're able to be a maestro in Adobe Illustrator and design products from thin air, then you're going to get very different results than, like me, if you have trouble drawing things in a straight line and mostly go find cool stuff and, you know, trace it as best you can and work like that. So it's a really good reflection of folks' creativity. What's neat about it is the time you spend learning it is really about learning design tools that can last a lifetime, things like Adobe Illustrator or Photoshop or CAD software. The actual process of printing it is so simple, you might be missing it. It is as simple as you're going and hitting print on the thing, dragging it into place, making sure the Wi-Fi is working, which is what we have our little extra delay for, and then selecting whether you want to cut or engrave the results. In fact, do you want to show the flyout, the cut versus engrave setting, so people can see? This is really all there is to it. So you can pick cut, or if she wanted to engrave that shape instead of cutting it, you can see there's an option for that. If this had been wood, it would have given her 3 different shades that she could have chosen to engrave from. Now, you can also, so there she goes. She just told the Glowforge to pretend this is a piece of wood, and she's got different shades to choose from. She can also say, under the engrave, she can also say to score it, which means make a very razor-thin line that doesn't go all the way through the material. Yeah?
Yeah, I was wondering, is this laser empowered to do etchings into copper like for a printed circuit board?
The question was, can the laser do etchings into copper like a printed circuit board? So I'm going to answer that a couple of different ways. One is that you can do PCBs with a laser, but it requires you to spray on a coating and then use the laser to remove the coating. Because it turns out copper is a really good mirror for infrared light. You know, I was talking about how different colors are absorbed and reflected. Well, copper is really good at reflecting light, which is really bad if your goal is to heat up the copper. So you put a spray on it and then engrave it off. And then you dip that in an etchant to make your circuit board. And there's a lot of folks who've been doing that online. Hooray. Okay. Picture or no, we're ready to go. There we are. One more push. Go for it.
The worst colors.
I know. Well, they're kind of the best colors. They're just not the right colors. So you can see this is the cutting operation where it's moving along. And you notice this is really quick. For those of you with 3D printers, this may be a little weird. Like, I can barely point out that it's working and it's done. I will tell you a fun fact. Do you see the Glowforge logo on the head of the device? That was, of course, engraved on the head of the device with the Glowforge. It's not decorative. The way that the machine knows where the head is when you first turn it on is it looks at the logo with the camera and aligns the head to the camera by looking at the location of it. So that's actually the way that it registers its own orientation. So just about done. It's doing a couple of cuts, and then we go. So we're talking about metal. So you can spray on and then engrave off the resist. That's commonly done. There's a few things that you can engrave and not cut. So most metals can be engraved but not cut. Aluminum, especially anodized aluminum, you can just engrave straight. Other metals, like titanium, you can engrave as well if you happen to have sheets of titanium laying around. Other materials, you can spray on something like spray paint. It's called Surmark. It has little tiny particles of ceramic. And when you engrave it, it fuses the ceramic to the metal. And the military's actually rated this for military use. It's not going anywhere. It's permanently chemically fused. So with Surmark, you can mark just about any sort of metal. So we can see and you guys remember, it wasn't like this was a design that was there before. Shell actually drew this while everybody was watching. So we could create this. And now the last steps, she's going to put these together. Almost done. With Surmark, you can engrave that. Glass is also another substance that engraves beautifully, but neither metal nor glass can be cut. So if you engrave glass, it frosts the surface, and it looks like if you'd sandblasted it or otherwise frosted the glass. And that's really cool for doing things like spice jars or the like. Glowforge can handle objects up to 2.5 inches deep in order to engrave them. And it can cut many materials that are 1/4 inch deep, a few materials that are 1/2 inch deep. So, keep an eye on our time, great. Nearly there. Any other questions? Yes? So the question was, most CNC machines, that's a category that includes milling machines, 3D printers, laser cutters, vinyl cutters. Most CNC machines use switches in the corners called limit switches. So the way they know where they are is they go up to the corner and they bang against the switches. We do something really different by using the camera in order to do that. And the question was, why? What does that get us? There's a few different things. One thing is, it helps save on the cost. Our goal is to take something that's normally $10,000 plus and get it down to the sub $3,000 price point, make it competitive with 3D printers. And while switches aren't expensive, it turns out that running the wires all the way around and getting them to go from the head and across the thing actually adds a non-trivial amount of cost. The second thing is, with the camera, we can actually grab images anytime the head passes under. So we can continually recalibrate and make sure that there are no problems as it goes, which allows us to keep an even tighter tolerance than we would otherwise. The third thing is, we had the camera, and we found out that it worked, so there was no need to go and add that. Although we do actually have an extra layer of redundancy where if for some reason, if something happened, if the machine was banged, it would be notified and it would pause so that you could go and be sure everything was working. And finally, I had a $10,000 industrial carbon dioxide cutting laser imported from China installed in my garage prior to, and as the principal reason why I founded Glowforge. And one of those limit switches had one screw come loose. So instead of being fixed, it was wobbly. And what happened was, the machine went to go calibrate itself, and it went to go hit the switch. Instead of hitting it, it pushed it backwards and rammed into the side and knocked the entire machine out of alignment and did a fair bit of damage. So even though switches are really old technology, they're also really fussy technology. And so being able to do it entirely solid state was pretty neat. Are you ready to show off to everybody? Come on over. All right. Could you put your arm, you're now going to be a wrist model. Put your arm right there. And let's see. Ooh. Ah. Big round of applause. Awesome. Thank you so much for your help. And I think we have time for 1 or 2 more questions before we're done. Yes?
How will it handle 3D relief?
The question was, how will it handle 3D relief? By which I think you mean engraving to different depths. So you can take a bitmap, like a regular picture that's grayscale, different shades of gray. Oh, this is going to be our last question. And it will interpret that so that the darker pixels are engraved deeper and the lighter pixels are engraved more shallowly. And we're in fact working on it so that we can do multiple passes, lowering the focus with each pass. So you can engrave as deep as 1/2 inch. So you can make really cool sculptures. And you can do that by creating it in CAD software, SolidWorks, something like that, turning it into a grayscale bitmap. You can do it by going into Photoshop. You can take a photograph and interpret it that way. And that gives you that immense degree of control over the depth. So thank you so much for coming out. In about 15 minutes, we'll have this Glowforge and the Wi-Fi return to its rightful home up at the booth. And we can actually start running prints for folks. So you can come by, we can make you a picture frame, we can make you a puzzle or any of a few other things. And we'll be around answering questions all day today and all day tomorrow. Big round of applause for Shell. And thank you so much for coming out.